Let us discuss what are queues. So if we have to draw a queue, it looks something like this. You draw it like a horizontal tunnel kind of a thing, and elements enter at one end and they leave from the other. For example, if I enqueue the element 10, so my queue is like this, and if I enqueue element 20 and then 30, so my queue has 3 elements. And when I dequeue from the front. So this side is called front of the queue and this side is called rear. So rear is where entities enter and front is where entities are taken out of from. So it is called first in, first out, because the element which enters first leaves first. It's like a tunnel. Whoever enters first leaves first. So this is contrasted from stack, where there is only one end at which we enter and we take out from. So in queue we enqueue at one end and dequeue from another end. So it is first in, first out. Now queue can be implemented both using arrays and linked list. So let's consider how it looks like when we implement using arrays. So ultimately there are two indices, front and rear. Okay, front is pointing to the first element more or less, and rear is pointing to the last element, and all the elements between them are the elements in the queue. So let's understand how things work. So let's say we enqueue 10 and then maybe 20 and then maybe 30. So front may be this and rear may be this. Now let's say we dequeue. So this element goes away and front is incremented. Front comes here. Let's say we enqueue another 40. So then the rear gets incremented. And slowly when we keep enqueuing, we might say that the rear has reached the end, and the front is also moving, so the front may be somewhere here. So assume front is here, rear is here, and these entities are these slots are vacant. So how do you insert a new element when rear is already at max -1? So you increment in a modulo fashion. You increment that max -1 plus 1 becomes 0. So modulo increment looks something like this. I will show that code. So the modulo increment looks like this. You say rear is equal to rear plus 1 % max. So if it is max -1, it becomes 0. So in a way you are treating the array to be circular, in the sense that the slot after the max -1 is 0. So you are treating the array as if the array is a circle, and after max -1 you get the 0 index, like that. You imagine that. So it's kind of a circular array, and the key concept is front and rear. And when you enqueue, rear moves +1. When you dequeue, front moves +1, and both front and rear move in a modulo fashion. They move in a circular fashion. So that's queue using arrays. And when you do a queue using linked list, it is quite simple. Instead of calling it the head, we call typically it the front. And so we enqueue at the end and we dequeue from the front. So basically you can say that we will use the functions delete at begin, okay, and insert at end. So it is almost using the same linked list functions. You can achieve it, but the catch is insert at end is order n, because insert at end you need to situate a pointer at the first node. You need to have a while loop and move it approximately n times and move to the last node. So that's costly. So what we do is we situate a pointer called rear at the last node, and once we have rear at the last node, we can happily, if we have to insert a new node, we simply malloc and we connect like that, and we are done. Okay, so in a queue implementation, typically we don't just have front or head pointer, we keep a rear pointer also, and then we do. Other than that, more or less it is plain linked list functions. So that is how the queue works. That's an overview. It can be implemented using arrays and linked list both. We will see both implementations.